Hello children, welcome back to 9th standard science class. In the last class we were discussing about Newton's second law of motion, and you have also learnt the mathematical formulation of Newton's second law of motion. F is equal to ma. Here a is nothing but v minus u by t. So now let us try to work out examples, problems given in the textbook. You copy the problems from the textbook. Let us work out the problems. See page number 120, example 9.1. A constant force acts on an object of mass 5 kg for a duration of 2 seconds. It increases the object's velocity from 3 meter per second to 7 meter per second. Find the magnitude of the applied force. Now, if the force was applied for a duration of 5 seconds, what would be the final velocity of the object? You have to find two things here. First one, magnitude of force applied you have to find. And then if the duration of the force applied for a duration means this time period is increased to 5 seconds, what would be the final velocity of the object? First 2 seconds time was there. If it is increased to 5 seconds, what would be the final velocity of the object? Now let us find the solution. Here let us write what is given. What is given here? Page number 120, 9.1. Let us write the solution. What is given? Here initial velocity is given and mass of the object is given. Mass of the object m is 5 kg. Mass m is 5 kg. And then what else is given? Try to find out. Initial velocity is given and time is given. What is the time? Time t is 2 seconds. And initial velocity u is 3 meter per second. And final velocity, it is the object's velocity increases from 3 meter per second to 7 meter per second. Here initial velocity is 3 meter per second and final velocity is 7 meter per second. Let us write mass m is 5 kg and initial velocity u is 3 meter per second and final velocity v is equal to 7 meter per second and time t is equal to 2 seconds. Now what is to be found out? You have to find the force, magnitude of force. You know the formula to find force. Expression for force, F is equal to M into A, where A is nothing but V minus U by T. So let us write it like that. F is equal to M into V minus U by T. Means A is equal to V minus U by T. Let us substitute this in place of A. M into V minus U by T. Let us substitute the values. M is 5 kg into V is 7 meter per second minus U is 3 meter per second divided by time t is 2 seconds. So what is this now? 5 into 4. 5 into 4 divided by 2. That is 20 by 2. So what is the force applied here? That is equal to 10 Newton. So the force applied, F, first one to find magnitude of force. F is equal to magnitude of force. F is equal to 10 Newton. What is the SI unit of force? It is 10 Newton. Now second one, see the time intervals. Duration of time is increased to 5 seconds. Then what you have to find? Final velocity should be found out. What will be the final velocity? To calculate when the time is increased to 5 seconds, how do you find the final velocity? Rewrite this formula. Rewrite this formula. So you will get final velocity V here. V minus U is equal to, rewrite to find. So in the second solution, what T is equal to 5 seconds. So now rewriting the formula, you get to calculate V. How to calculate? To calculate V, rewrite the formula. Calculate V by rewriting the equation. Rewriting the equation. Which one? How to write? See, V minus U. V minus U is equal to what it is? F into T divided by M. So how to rewrite? V minus U is equal to F into T by M. F into T divided by M. So now F. What is F here? F is 10 Newton, you have found out. And T, time T is given here 5 seconds and divided by mass M. So that is equal to F is, we have found out here 10 Newton force. 10 into T is 5 seconds divided by mass M is 5 kg divided by 5. That is equal to 50 by 5. So how much it is? 50 by 5. How much? 10. So V minus U is 10. But we want here V minus U is equal to 10. But what is U? V minus U, you know. V, it is 3. V minus U is given there 3 meter per second, that is equal to 10 now. So V minus U is 10. Now V is equal to 10 plus 3. How much? 13 meter per second. So what is the final velocity? V is equal to, what would be the velocity? Velocity V is equal to 13 meter per second. Got it now? How to find? First write whatever given. Mass is given 5 kg. Initial velocity is given 3 meter per second. Final velocity is given 7 meter per second. And time T is 2 seconds. So using this data, you have to find magnitude of force applied. F is equal to M into A. What is the formula you have learned? Force F is equal to M into A. What is A? A is nothing but V minus U by T. Let us write the formula as F is equal to M into V minus U by T. Now that is equal to M is 5. 5 into 7 minus 3 by 2. That is 10 Newton force. So the force applied is 10 Newton. And the second thing to find out, T is given here, means the duration of time is increased to 5 seconds. Then what will be the final velocity you have to find? To calculate the final velocity V here, you have to rewrite the formula. How? V minus U is equal to F into T divided by M. So V minus U is 10. It is V minus U is 10. But U is given there. V minus U is 3 meter per second, that is 10. V is equal to 10. When it goes to that side, 10 plus 3, 13 meter per second. So when the duration of time becomes 5 seconds, then what would be the final velocity? It is 13 meter per second. I hope you have understood the problem. Now let us move on to the next problem. 9.2. What is the problem? Let us see. Problem number 9.2 from page 20. Sorry, 21. Page 21. 121. So 9.2 say, which would require a greater force accelerating a 2 kg mass at 5 meter per second square or 4 kg mass at 2 meter per second square. What is asked here? Say, which would require a greater force accelerating a 2 kg mass at 5 meter per second square or a 4 kg mass at 2 meter per second square. How do you find? Let us find the solution. You know that F is equal to m into A. Here what is given? F is given. F you have to find. Mass is given and acceleration is given. You have to find force here. So two instances are given. An object of mass 2 kg is accelerated to 5 meter per second square. This requires more force. Or a 4 kg mass, object of 4 kg mass is accelerated to 2 meter per second square. So which would require more force you have to find. First you have to find the force, magnitude of force in both the instances. So let us write what is given here. Write what is given. Mass is given m1. Let us consider for first object m1 is equal to 5 kg. 2 kg. Sorry children. m1 is equal to 2 kg and a1 acceleration a1 for first object it is 5 meter per second square. A1 is equal to 5 meter per second square. Now for second object, this is for first object. Now for second object, m2 is equal to 4 kg and a2 is equal to 2 meter per second square. 2 meter per second square. Now let us find magnitude of force in both the cases. You know that F1 is equal to, first one now, M1 A1. So F is equal to M into A. Means F1 is equal to M1 into A1. So M1 is 2 kg into A1 is 5 meter per second square. That is 10 Newton. And for second object, F2 force applied is F2 is equal to M2 into A2. So that is equal to M2 is 4 kg into A2 is 2 meter per second square. That is equal to 8 Newton. So 8 Newton force is applied. Now which would require more force? First one or this one? What does this implies? This implies that, so this sign says, this implies that, see F1 is greater than F2. Yes or no? F1 requires 10 Newton force, F2 requires 8 Newton force. So F1 is greater than F2. Then which one requires more force? Accelerating 2 kg mass at 5 meter to 5 meter per second square requires more force. Yes, thus accelerating a 2 kg mass at 5 meter per second square would require more force or a greater force. So now accelerating, therefore accelerating 2 kg mass at 2 kg mass at 5 meter per second square would require a greater force. Yes, this completes the second easy problem. The same way the number you can change and work out the problem. Now let us move on to third problem worked example. See in page 121, 9.3, a motor car is moving with a velocity of 108 km per hour and it takes 4 seconds to stop after the brakes are applied. Calculate the force exerted by the brakes on the motor car if its mass along with the passengers is 1000 kg. So what is asked? You have to calculate the force exerted by the brakes on the motor car. Mass is given, mass of the car along with its passengers it is given 1000 kg. Now velocity is given. Which velocity it is? A motor car is moving with the velocity of 108 km per hour. It is moving first only. So it is initial velocity. Then it takes 4 seconds time to stop after the brakes are applied. Then it comes to rest. After 4 seconds, brakes applied and it comes to rest. Means what is the final velocity? It is 0 meter per second. Initially it is moving with a velocity of 108 km per second. Then after 4 seconds when brakes applied, it comes to rest. So final velocity is 0. Now we can find the magnitude of force applied. So let us write what is given first. What is given? Mass of the car along with its passengers given 9.3. Mass M is given 1000 kg. Then what else is given? Initial velocity U is given. Initial velocity U is equal to 108 km per hour. Means kilometer per hour you have to convert it into meter per second. How do you convert? Kilometer into meter means 108 into 1000 divided by 1 hour is equal to 60 minutes into 60 seconds. So it is 60 into 60, or you can write 3600. 1 hour is equal to 60 minutes into 60. That is 3600 seconds. Seconds it is 3600 seconds. Now cancel. 36 ones are 36 threes are. So that is equal to 10 threes are 30 meter per second. So what is U? It is 30 meter per second. And what is V? Time T is given. How much? 4 seconds. So time T is 4 seconds. Then V, it comes to rest. So it is 0 meter per second. Now these data given, using that magnitude of force applied you have to find. So F is equal to M into V minus U by T. What it is? M is given 1000 kg. 1000 kg into V is given 0 minus U is given, it is 30 meter per second divided by time T is 4 seconds. So you can write here kg, here meter per second and seconds also, or you can directly write also. So that is equal to 1000 into minus 30, that is minus 30,000. 1000 into minus 30, that is minus 30,000 divided by 4. How much it is? 4 how many times? 4 sevens are 28. 2 remains 20. 4 fives are 20 and 2 zeros. So that is equal to, you got negative sign here, N. How? What is the force applied here? It is negative, minus 7500 Newton. Why is here? What does negative sign indicate? Here the force applied is in the opposite direction. Brakes are applied in the opposite direction of its motion and it comes to rest. Velocity decreases. So what is negative sign indicates that the brakes are applied in the opposite direction of motion, means force is in the opposite direction of its motion. So the answer is minus 7500 Newton. So SI unit of force is Newton, or you can also write kg meter per second square. F is equal to m into a. M is measured in kg and mass. SI unit of mass is kg and SI unit of acceleration is meter per second square. Instead of Newton, you also can write kg meter per second square also. So this is the third problem now. Now let us move on to another problem, 9.4. A force of 5 Newton gives a mass m1 an acceleration of 10 meter per second square and a mass m2 an acceleration of 20 meter per second square. What acceleration would it give if both the masses are tied together? If both the masses were tied together, what acceleration it would give? Here mass is not given. With the given data, you can find the mass because force is given, acceleration is given, so you can find the mass. m1 and m2 can be calculated here. So what is the force given? 5 Newton, a mass m1, an acceleration of 10 meter per second square. To an object of mass m1, it gives an acceleration of 10 meter per second square. Force applied is 5 Newton. And the same force 5 Newton is applied on another object m2 and it gives an acceleration of 20 meter per second square. So let us find mass. Then what you have to find? What would be the acceleration if both the masses were tied together? First we have to find mass m1 and m2 we have to find first. Let us see how to find the mass. Right, what is given? Force N is given. Force F is given, that is 5 Newton. Force F is 5 Newton. And what else is given? A1 is given. A1 acceleration of the first object is given. So it is 10 meter per second square. 10 meter per second square. Now m1 must be found out. How to find m1? M1 can be found. You know the formula. F is equal to m1 a1. Now you know F and you know A1. So M1 is equal to F by A1. So how do you find F you know? A1 you know given. Force is given 5 Newton and A1 is given 10 meter per second square. So what is M1? M1 is equal to F by A1. So that is equal to now F by A1 is equal to F is 5 Newton divided by A1 is 10 meter per second square. So what it is? 5 ones are 5 twos are. Half means what? 0.50 kg. So let us write two digits here, 0.50 kg. Now let us find, this is first one, and M2 let us find. M2 is equal to, same formula, F by A2. So M2 is equal to F by A2. You know the formula, F is equal to M2A2. Means M2 is equal to F by A2. That is equal to F is 5 Newton divided by A2. What is A2? A2 is equal to 20 meter per second square. What is A2? 20 meter per second square. So now 5 Newton force is applied and to object M2 it gives an acceleration of 20 meter per second square. Now this is equal to 5 ones are 5 fours are. So 154 means how much? 0.75 kg. So you got now M1 and M2. What is asked here, if these two masses are tied together, then what will be M1 and plus M2? If the two masses were tied together. Two masses were tied together. M1 plus M2. What it will be? Tied together, let us write here, M1 plus M2 is equal to, M1 is 0.50 kg, 50 kg plus M2 is 0.75 kg. So what is the answer now? 0.25, sorry children, 154 means 0.25 kg. Sorry, very sorry children. It is equal to 0.25 kg. So what is the, when two masses were tied together, M1 plus M2 becomes 0.50 kg plus 0.25 kg. That is equal to 0.75 kg. And now you got the combined mass. M1 plus M2 is 0.75 kg. Now, what would be the acceleration? See, the question is, what acceleration would it give if both the masses were tied together? Now, acceleration A is equal to, you know that F is equal to ma. Acceleration A is equal to F by m. What is acceleration A now? A is equal to F divided by m. That is equal to F is 5 Newton divided by m is this combined mass 0.75 kg. So now simplify into 100 into 100. So how much you get? 500 by 75. 500 by 75, that is equal to, how much you get? 6.67 meter per second square. Simplify, 67 meter per second square. So this 6.67 meter per second square is the answer. So it gives the object and when two masses were tied together, it gives an acceleration of 6.67 meter per second square. So this is how this problem is to be worked out. And one more problem is that you try to work out at home. It is easy there. The velocity time graph of a ball of mass 20 gram moving along a straight line on a long table is given in 9.9. Here what it shows, how much force does the table exert on the ball to bring it to rest. How much force is to be applied on the ball to bring it to rest. You have to find that. So what is given here? The initial velocity of the ball is given 20 meter per second. So here you can see 20 meter per second. And what is due to friction force exerted by the table. You know that the table exerts the friction force, so that what happens, the velocity of the ball decreases down to 0. Look at the graph here. The velocity from 20 centimeter per second, it decreases to 0. So in 10 seconds, thus u is equal to 20 meter per second, v is equal to 0, it comes to rest. So v is equal to 0 centimeter per second at time t is 10 seconds. Now velocity time graph is a straight line. Here you are observing. It is clear that the ball moves with a constant acceleration. So the acceleration is a is equal to v minus u by t. Substitute the values and try to find the answer. Then find force. After finding acceleration, you will easily calculate the force. F is equal to m into a. Let us learn in the next class. See you then.